All right, here we go. So second one. Now, I want to tie into the aim here a little bit. How do we determine angle measurements using of a circle using tangents? So this whole lesson is really about different variations of what the role that tangents can play in these problems. One thing I didn't say is if you really want to give this a shot, because I'll post this, change angle AOD to like, I don't know, change it to like 40 degrees or something, or no, 60 degrees. Change it to 60 degrees, and then try to do this problem again and answer all the questions. I mean, really, we answered all those questions as we did it, and that's, to me, try not to go in order. Just go with the way that you see it. All right, so back to the lesson. So now we're going to talk about tangents. So what's a tangent? Besides something we do in class all the time of going off on a tangent is a line that intersects the circle in exactly one location. So a tangent's, I couldn't find a straight edge, sorry, don't judge me. A tangent's going to look like that. That's a line, right? And it just kisses the circle in one spot, all right? Now, you're going to deal with tangents for a while in your math career, so it's important that you understand what it means. These are all tangents, all right? One location. Now, is this a tangent? No, that's not a tangent. That's not, oh, it hits it in one spot. Yeah, but if it were to continue, it would hit it in two spots. So that's not a tangent. All right, tangent, not a tangent. All right. So there's this theorem. Tangent segments drawn from the same external point to the same circle are congruent. So I'm kind of wishing I didn't draw this here, but whatever. So I'm going to pick a point. All right, point. Creatively labeled P for point. Now, if I were to draw a tangent from that line to, that point to a circle, the circle, it would look something like that. But I didn't have to draw it that way. I could have drawn it the other way. So if I also draw it this way, it would look something like that. Now what I want you to see is that from point P to, let's call this point of tangency A, and this point of tangency B, this line segment PA would be congruent to this line segment PB. Peanut butter. All right, so PA would be congruent to PB. All right, and that's always the case, only with tangents. All right, so boom, boom. Capiche? All right, moving on. All right. So a circle inscribed within a triangle. A circle inscribed within a triangle. All right, so what are we doing here? Well, if we use that relationship we just had, right, and I kind of label this up a little bit, I want you to realize, I'm going to call these 3 points of tangency D, E, and F. Now, what I want you to see is that these two guys are the same, these two guys are the same, and these two guys are the same. So if I gave you, let's say I told you this piece here was 5, and this piece here was 8, and this piece here was, whatever, 12, 13, 14, all right? That's enough to figure out the perimeter of the triangle. So you can sit there and go, hold up. If this is 5, then I know this is 5. And if this is 8, then I know this is 8. Well, hold on. It's not this outside piece that's 14. The whole piece is 14. But if this is 5 and this is 14, I can subtract and get 9, which makes this piece 9. And suddenly your perimeter, right, add up the lengths of all 3 sides, is going to look like 5 plus 8, that's this side, plus 8 plus 9, that's this side, plus 5 plus 9, that's this side. All right, and you'll get a perimeter, whatever that is, 13, 17, 30, 44. All right, so that's a type of example that can come up. All right, moving on. Another theorem. If a line is tangent to a circle, all right, well, I'm just going to draw the line then. So a line tangent to a circle Again, there's my tangent. And this is my point of tangency, we said. The line is perpendicular to the radius drawn to that point of tangency. So hold on. I can draw a radius. I need the center, right? Again, we'll call it center O. So if I drew a radius to that point of tangency, I'd be looking at this radius. And they're telling me that this is perpendicular. And of course, if you look at it, it does look perpendicular. Throw a boxy thing in there. I'm golden. All right? So that's a somewhat important theorem. We can make a lot of different problems from that. So if a line is tangent to a circle, check. The line is perpendicular to the radius drawn, perpendicular to this radius drawn to that point of tangency. All right, I can live with that. All right, I'm going to stop there.